All right, hey guys, let's talk about solving multi-step inequalities today. I got a couple of examples here. I'm going to show you my way that I like to do them. So let's go ahead and start in here. So we got an inequality here, and I like to treat inequalities a lot like equations. They're pretty much identical, except for the fact that they don't have an equal sign, right? They have one of our four inequality signs, so they're very similar to equations, especially how we solve them. So kind of the idea is the same. At least for me it is, okay? So I like to scan through here. I like to identify any like terms that need to be combined and possibly any distributive property or anything like that that might need to be ran through, which we don't have any distributive property, but we do have a pair of like terms here. So we got a constant here and a constant here. These two guys need to get combined on the same side of the inequality. Now, me particularly, I don't like my variable terms to be on the right side of the inequality, but that's okay. I mean, in the end, at least, I don't. So let's go ahead and work this out, and I'll fix my inequality, the solution in the end. So I'm going to go ahead and leave that 7y on the right. I'm going to get rid of this guy here. I'm going to do an inverse operation. I'm going to subtract 11 to undo adding 11 from this right side of the inequality. Now again, this our sign here splits the inequality into a right side and a left side. Okay, so if I subtract 11 from the right side of the inequality, I have to come over here and subtract 11 from the left side. So that leaves me with 7y on the right side. And my symbol is going to stay the same here because I did not multiply or divide each side of the inequality by a negative number. We'll see that in our next example, right? That's when we actually flip the symbol. And on the left side here, I've got this calculation, negative 31 minus 11, which is going to give us a negative 42. Okay. Now let's keep on working here. Let's keep working towards getting y by itself on one side. Now again, I'm just going to leave the y on the right side, but I will fix that here in the end. So let's go ahead and undo this multiplying by 7, right? We've got all of our like terms combined. So my last step is to get this variable term, right? We got to release that multiplying by 7 so we can get that y by itself. So I have to divide by positive 7. Divide that side by positive 7. So I divided each side by a positive 7. So there again, I keep my symbol the same, right? Because I did not divide by a negative 7. And 7's cancel here. It leaves me with y by itself. And on this left side, I got negative 42 divided by 7, which is going to give us a negative 6. Now this is a good answer. That's just a fine answer right there. It just typically, if this were a test or multiple choice or something like that, typically they won't write the answers with the variables on the right. Now, not to say that they never will, but you need to actually understand how to get both versions of the correct answer from this, okay? So this is a true solution. This is good. It's just typically it's not how it's written, and it's definitely not how I would graph it. I always graph with my variable on the left side. So let's just fix this. It's pretty easy. You just take this solution, pick it up, and flip it. Okay, so the y is going to come to the left, and the negative 6 is going to come to the right. And you have to actually think about that symbol actually flipping itself too. Okay, so that's going to turn into a greater than or equal to sign. These two solutions are actually equivalent. They mean the same thing. If you really think about it, and play around with the thought process here, it is the same, right? Negative 6 always has to be less than or equal to some number y, which means the same thing as some number y always has to be greater than or equal to negative 6. Now, I only ever graph from this solution right here. Okay, so I always get my variable on the left, and then I graph. Because when you have your variable on the left, your arrow on your graph will always match the direction of your arrow in your inequality. So let's just go ahead and look at that. Okay, so negative 6, I'm going to show 0, negative 6 somewhere to the left. And that's going to be a closed circle because we have the or equal to sign, so it's going to be a closed circle. Y can be any number in the world as long as it is greater than or equal to negative 6. So numbers greater than negative 6 will be in this direction to the right. And there's our corresponding graph. Okay. Negative 6, closed circle, arrow to the right. It matches the direction of the symbol. See, a lot of people will get this solution, but they might match the graph with the arrow pointing to the left since that symbol is less than. Okay, so make sure you get the variable on the left. That way your arrow will always match the direction of your symbol in your solution, right? All right, let's go on and do another one here. Let's do one where we actually have to use our trick. I call it the trick. Okay, so same things. Scan through here. We got a couple of like terms that need to be combined. All right, we got that positive 4 and that negative 23. I'm going to go ahead and get them together over here on the right side. Leave my variable term on the left. So I'm going to subtract 4 from this side. Gone. Subtract 4 from that side. All right, I subtracted 4 from each side, so my symbol will stay the same. That leaves me with negative 3x on the left. And on the right, we got a calculation. We got to take negative 23 and minus 4, which is going to give us a negative 27. All right, I've got all of my like terms combined. My next step is to get that x by itself, right? So I have to undo that multiplying. Right, there's a multiply right there. We have to undo that multiplying by 3 to get x by itself. So that's my inverse operation. I'm going to divide that side by negative 3. And I got to divide that side by negative 3. And remember our rule here, I call it our little trick, right? Anytime you ever multiply or divide each side of an inequality by a negative number, which we did, right? We divided by a negative number. You must flip your symbol in the next step. So since we multiplied or divided, right, in this case we divided by a negative number, we flip the symbol in the next step. Okay? Everything else stays the same. Negative 3's cancel, leaves us with x by itself on the left. And on the right, we got negative 27 divided by negative 3, which is going to give us a positive 9, and there's our solution. Very good. And just for the heck of it, we have an equivalent solution, right? If we take that and flip it, right, this would also be the same as 9 is greater than x. Okay, it's good to know how to get both forms of these, because I have seen on tests and things like that, them write the solutions in both formats. So you really need to know how to go back and forth between the two. It's very easy. You just flip it, right? The symbol flips as you pick it up and mirror it, flip it, right? Let's go ahead and graph that solution. So we're going to need to show positive 9 on our number line. I like to show 0 if I can. I'm going to show 0 a little farther to the left. So I got positive 9 somewhere to the right. And we got an open circle this time because there's no or equal to, right? So we got an open circle indicator on the 9. And remember, we always graph from the solution with our variable on the left, at least me, I do. That way our arrow matches the direction of the symbol, right? X can be any number in the world as long as that number is less than 9. So numbers less than 9 are going to be to the left, right? Which also matches the direction there, right? So there's our graph, there's our solution. And there you have it. Solving a couple of inequalities, multi-step inequalities there. Hope that helps.